Determine the number of solutions. We're going to go over here to, it's right here. It's actually I don't want to do that one. I'm going to do this one. Okay, this should say 3, 5. I messed up. How many solutions can an equation have? So let's look at this. It says in this activity you will explore 3 equations. This is equation number 1. Okay? Solve the equation for x. So 2x plus 6 equals 4x plus 2. So if I'm going to solve this, I'm going to we're going to subtract 2x from both sides. Oh, and I know I forgot to put this down. And that means these are going to be eliminated. So I bring the 6 down and equal sign a 2x plus 2. I subtract 2 from both sides. I get 4 equals 2x. I divide by 2 on both sides, and I get 2 is equal to x. Okay. What does it mean for this value to be a solution? It means that when I plug this number in up here for both of these x's right here, that both sides of the equal sign will be equal to each other. So let me prove it real quick. Oh, I'm going to do red. So 2 times 2 plus 6 equals 4 times 2 plus 2. So that's 4 plus 6. This is 8 plus 2. 10 equals 10. Both sides of the equal sign equal each other. It means this is the answer to the question. So, this is the equation we just did. It says plug it in for 2. Well, I just did up here when I did that. Okay. Now, they equaled each other. Now, if I was to plug 5 in, because that's what it says to do. It says to choose 5. So I'm going to plug in 5. So 2 times 5 plus 6 equals, nope, not 2. 4 times 5 plus 2. 10 plus 6 equals 20 plus 2. 16 does not equal 22. So it would say 16 equals 22. So that is not an answer. Because these two do not equal each other, that means that 5, this right here, is not a solution. It doesn't work. It doesn't make this a true statement. Okay, so we're going to go to the next one. And it says, now consider equation number 2. Choose any 5 values for x and then enter one at a time. Okay, so I'm going to pick 5 values. Well, I'm going to come over here. 2x plus 6 equals 2x plus 6. Okay, I don't know. Let's say that we're going to pick x equals 6. I don't know. 2 times 6 plus 6 equals 2 times 6 plus 6. 12 plus 6. Look at this. Do you notice something? Look at that. They equal each other. So let's pick a different number. When x equals negative 3. So 2 times negative 3 plus 6 equals 2 times negative 3 plus 6. That would get negative 6 plus 6. Negative 6 plus 6, 0 equals 0. Look at that. It works again. So these are both solutions so far. So let's pick it again. Like x equals, 50. So 2 times 50 plus 6 equals 2 times 50 plus 6. 100 plus 6 equals 100 plus 6. 106 equals 106. Okay, I'm just going to do 3 of them. But do you notice that every single time these answers are solutions? Each time they're a solution. Okay, now that we did that, let's look at this equation. What do you notice about the coefficients? Okay, what do you notice about the constants? So, if I'm looking at the coefficients, look at this, the coefficient here, the coefficient here. They are the same. Now let's look at the constants. Look at that. They again are the same. How many solutions does equation 2 have? I'm pretty sure that no matter what I put in there, that it's going to be a solution. So I'm going to say there are infinite solutions. Okay, let's go to the next one. And let's see, now choose any 5 again. So I'm going to come over to the side. It says 2x plus 6 equals 2x plus 9. Let's look at this. Okay, as I look at this, I'm going to pick x equals 2. 2 times 2 plus 6. 2 times 2 plus 9. 4 plus 6 equals 4 plus 9. 10 does not equal 13. Let's try another one. Let's pick x equals negative 5. 2 times negative 5 plus 6 equals 2 times negative 5 plus 9. Negative 10 plus 6. Negative 10 plus 9. Negative 4 does not equal negative 1. They don't equal, so that's not a solution. Let's say x equals, 15. 2 times 15 plus 6 equals 2 times 15 plus 9. 30 plus 6, 30 plus 9. 36 does not equal 39. Okay, so as I do this, let's look at this, guys. If I was to subtract 2x from both sides, we would get 6 does not equal 9. Will 6 ever equal 9? No. So let's look at this. Again, we're going to look at the constants and the coefficients. Okay? So if I look at my coefficient, if I look at my coefficients, they are the same. If I look at my constants, they are different. Now let's go back up here. We didn't do that with equation number 1. So let's look at equation number 1. So if I'm looking at my constants and I'm looking at my coefficients, if I'm looking at my coefficients, they are different. Look at my constants. They are different. And this one right here, that's a horrible star. There we go. Constants, it doesn't matter what they are. But the coefficients being different, that is super important to know. Okay, So now let's go over to our actual lesson. So, number of solutions. How many solutions can there be? There can be 3 different solutions. You can either have no solution, 1 solution, or infinite solutions. Up until today, we've only dealt with 1 solution. This is the one that we've been dealing with. Okay? It's where the variable, and they're using a as a number. Okay? So it's going to have a variable and it equals a number. Okay? So that's 1 solution. No solution is when you're going to get down to this stage right here, and they're both numbers, a lot of times integers, sometimes rational numbers, but they're not going to equal each other. Then infinite solutions, when you solve the equation, it will always be that this stage right here equals each other. Okay? So let's go to this next one. So let's look at this. So I need to solve this. Okay, remember, distributive property always comes first. So I'm going to multiply 6 times x and get 6x. 6 times negative 3 gets minus 18. Then I still bring my plus 10 down. I don't do anything with that. Then I take the 2 and I multiply it by 3x and I get 6x. Take my 2 and multiply it by the negative 4 and get negative 8, or subtracting 8. Okay, now make sure that you combine like terms. Okay, these 2 right here are like terms. Negative 18 plus 10 is going to get you a minus 8. Can't do anything with the other side, so we leave it alone. Now, I have variables on both sides of the equal sign. Okay, do you see? Oops, I didn't mean to mark that one. I have variable here, I have a variable here. I want to get rid of the variables. If I do that, look at this. These eliminate and these eliminate. They go bye-bye. I'm left with negative 8 equals negative 8. What that means is no matter what number I plug in for x, it's always going to come out with a solution like this. Okay? It is all real numbers. Okay? Is always true, because any number can be substituted in for the equation to make it true. Any number. Okay? So we could pick any number we wanted. So, I don't know, 7. If I do that, I would get 6. 7 minus 3 is 4. Plus 10. This would be 2. This would be 21 minus 4, sorry. This would get 24 plus 10. Oh, it says equals 16 equals 16. Oh, well, I'm ignoring this part. Oh, it says replace with 4. I didn't do 4. I did 7. Okay, I get 34 on this side. Over here, I would have gotten 2 times, what is that, 17? Which is, again, 34. Okay, so no matter what, it will work. So you don't even have to do a lot of work with this. All you have to look at is in the simplified form. In the simplified form, actually, we're going to multiply here and get 6c. Multiply here and get minus 12 minus 2c equals, multiply here, 4c plus 16. So 4c minus 12 equals 4c plus 16. Is that exactly the same on both sides of the equal sign? No, it's not. So this is not going to be infinite solutions. So then, I'm actually going to do this one next. I'm going to multiply here, and I get 6p minus 3 equals 2p plus 20 plus 1. So 6p minus 3 equals 2p plus 21. They are not exactly the same on both sides of the equal sign, so that is not going to work. Then I take 8 and I multiply and get 8x. Multiply here and get minus 72. Multiply here and I get 12x. I multiply here and I get negative 72 minus 4x. So 8x minus 72 equals, this is a like term with this, 8x minus 72. They're exactly the same on both sides. So this one is going to be an answer. And let's check the very last one. If I multiply here, I get 5x. If I multiply here, I get minus 10. Then I subtract my 20. Multiply here, I get negative 5x. Multiply here, and I get plus 30. 5x x minus 30 and negative 5x plus 30. Those are not exactly the same on both sides, so that one will not work. Okay, now let's come over here to this one. Okay, so now I'm going to multiply here, and I get 32. Multiply here, and I get negative 16x. Multiply here, I get 12, and minus 20x. Make sure that I combine like terms, because this right here, wrong side of the equal sign. This right here is not either. But these two are. Look at that. Those two are like terms. Oh, I should have done that in a different color. That's okay. There we go. These two are like terms. Negative 20x plus 4. That would get a negative 16x. Okay, so if I subtract or add 16x to both sides, and I look at this right here is going to cancel out, and this right here is going to cancel out, or they are eliminating each other. I bring down the 32. Does 32 ever equal 12? No. So because when you solve this equation, you got 32 doesn't equal 12. That means this will never be true. Okay, so there's no value that we can plug in that will get us a true statement. So this solution is no solution. Okay, so we do the same thing down here. Actually, are these the same ones we did a minute ago? No, they're not. Okay, so I'm going to take this and I'm going to multiply in 5b. And this one right here, it'll be 15 minus 2b equals 2b plus 3. I combine this one with this one, and it's 3b plus 15 equals 2b plus 3. If I was to subtract 2b from both sides, I would get b plus 15 equals 3, subtract 15, and get b equals negative 12. So that comes out to an actual answer. So that is not going to be it. So next, I take this and I get 4d minus 12 plus 5 equals 3 times d is going to get 3d. 3 times 2 is going to get 6 minus 7. Combine like terms right here, and I get 4d minus 7 equals 3d minus 1. I solve this. I subtract 3d from both sides. I get d minus 7 equals negative 1. I add 7 to both sides, and I get D equals 6. That actually comes out with a solution. So that is not going to be, okay, so then this next one, I take this and I multiply it. I get 3x. I multiply here, I get plus 15 equals 5 times x, and it will be 5x. 5 times 3 is 15. Then minus 2x. 3x plus 15 equals 3x plus 15. These are exactly the same, so this is going to be infinite solutions. So that's not going to work. Last but not least, negative 10y plus 18 equals, I multiply here, negative 15y plus 35 plus 5y. I get negative 10y plus 18, negative 10y plus 35. If I add 10y to both sides, I get 18 equals 35. That will never be true, so this is no solution. So my answer is D. Okay, so again, we were talking about this earlier. So if I look at something that has no solution, and I look at the coefficients are the same. Now look at the coefficients here. The coefficients on this one are different. And then if I look at the coefficients on this one, they are the same. So if the coefficients are different, automatically it's going to be one solution. Now let's look at the constants here. If I look at the constants here are different. Now, for one solution, they could be the same or different. It doesn't matter. Then over here, for infinite solutions, if they both have the same constant and the same coefficient, they have infinite solutions. If it's no solution, there will be the same coefficient, but different constants. Okay. So in order to create, so I want something that is an infinitely many solutions. That means both sides of the equal sign have to equal each other. Well, in order to do that, I have to simplify the left-hand side. So if I simplify this, I have, I could do this. I have these three things that I need to, what is that called? Simplify. So 6x minus x will be 5x. 5x plus 2x is going to get me 7x. So we have 7x plus 4, and we want infinite solutions. We just said a minute ago, if it's infinite solutions, they have the same coefficient and the same constant. So same coefficient, same constant. There you go. Down here, again, I have to have the same. So first I need to simplify. So 4x, I multiply this through, and I get minus 2x, multiply here, minus 10. So I get 2x minus 10. So it has to be the same on both sides. 2x minus 10. Okay, now no solution. Okay, again, I have to multiply through. 6x plus 12. Then I need to combine like terms. Okay, so this is a like term with this. So I need to combine those and get 5x. Now, in order for it to be no solution, the coefficients are the same, but this right here has to be different. So any number other than 12. This is not going to be 12. So So let's do it down here. Like terms. These are like terms along with this. So sometimes I like to rewrite it just so that they're right next to each other. So if I simplify this part right here, that is going to get me 4x minus 6. Okay, so the other side, the coefficient has to be the same, but this number right here has to be different. So this is anything other than 6. It could be 3, it could be 5, it could be 9, whatever. It could be the negatives of those. It just can't be 6. Okay, there we go.